Tomorrow we get in a car for about an 11 to 14-hour drive to go to Kentucky for VEX Worlds. So the way it works for us is our season actually runs from last year's Worlds to the next year's Worlds.
Last May, a new competition was unveiled. So they began working on their robot at that point in time. Once they completed their robot, they started competing back in December of 2017. And they competed well enough to go to states. And once they went to the Delmarva state competition, they won at that championship to get here.
I'm co-captain, so I'm just second in command of supervising. Anissa Katak is our captain. She takes care of everything. She is an expert in pretty much everything, and there's a lot of stress that goes on the captain, but she handles it pretty well. There's Michael, and he's our main mechanical, and he just basically makes sure that everything works properly. He's a very big part of building. Patrick is a programmer and also mechanical, so he helps out with those two areas if one of us is struggling. Rents, he's like kind of also backup mechanical, so he works on that a lot. Jeffrey takes care of all our organization, which is, it sounds like it's not a lot, but organization is like key in this club, because if you can't find something in a competition, you're out. Like, it's not gonna work. And then we have Corey, who does programming. He's the other driver, and he does mechanical as well.
It's really great that they come together and they become friends and they have mutual things that they like and enjoy, and that they're even able, that the mechanical person gets along well with the programming person. That's very unique, and they enjoy their time even off the robotic field.
As a team, we've worked hard together. It's taken a lot of effort to design the robot and be able to make it work well. So it's not just a good robot, it's a robot that we can drive easily. I think that's one of the factors that we see other teams do, and they have a robot, but it doesn't work that well because their team isn't as coordinated as we are. Because like, we're having driver practice, we're talking, we're communicating. So what we can do is we can pick up what's called a mobile goal, which we stack cones on, and then we can take that and put it into different point zones. And the point zones, depending on where you put it, depends on how many points that mobile goal is worth.
We use Robot C, which is also a beginner type. It's really easy to learn. We have to program autonomous, which is the robot driving itself, basically. And then we have to program teleop, which is the driver.
I think one of the things that you might never notice is the fact that we're actually using 2 batteries. Normally, robots will only use 1. But we're using a power expander so we can actually split the load between different parts of the robot. And because of that, it took some hoops to make sure that we could plug everything into the brain of the robot, but it ended up working out fine.
This has brought so many great opportunities to me with scholarships and learning what I want to do when I get older, and like when I go to college, what I want to major in. I never knew that I would be interested in anything like this, like computer software engineering, anything like that. So it's broadened my perspective of what's out there in the world.
At the state level, they had a moving chassis that could only pick up a mobile goal and score points. Now they have a robot that can do multiple functions. They could pick up a mobile goal, a cone, score on high goal. They've come a long way since then. So they are more competitive against other states and countries that are going to be there.
I think it's going to be very packed, but an amazing experience. I mean, even if we don't win, it's just going to be really great to be there and with everyone else and just see everyone else's designs and what they did and what we could improve on.